think you have not done some of what we're about to do. So, first things first. Go to mode. And wasn't it just about a week ago or 4 or 5 days ago that I told you to go to degree mode? Yeah. All right. I want you to go back to radian today. I know.
On any test, are we going to have to switch between?
Yes.
Are you going to tell us when?
No. Tom?
Yeah. I still don't get the difference between radian and mode.
You don't know the difference, right? Stick around for tomorrow and I'll tell you the difference. I'll give you the long of it, the short of it. I'll give you the short of it right now. A radian is a way of measuring angles, and it's about 57 degrees. Okay, so 1 radian is about 57 degrees. I'll tell you a little bit more about it tomorrow and why we convert back and forth. Mathematicians actually like radians because branches of mathematics like calculus work out a little nicer if you work in radians. Physicists, scientists, they like degrees because we're very accustomed to degrees. That's what we measure most of the things in. Okay, so when you're in science class,
So which one do you like?
I actually like them both. Okay, when you're in science class, you're going to be in degrees. Okay, when you're in calculus class, you're going to be in radians. Starting now in precalculus, Danny, you're going to be in both, and you're going to have to figure out when. So I'm laughing because my daughter loves that song by Hannah Montana. Yes, sorry, or Miley Cyrus. I really haven't figured it out. Sorry. But doesn't she have albums out by both names now?
Yes, but Hannah is like about being a
All right. Evan and Tom, I'm going to say wait just for a second because I want to show you some more things. All right, so you make sure you're in radian mode, and then down below, instead of being in function mode, go over to para, which stands for parametric mode. And we have not done, I don't think, have you done anything with parametric mode yet? No. So this is your first foray into parametric mode. We're not going to talk too much about that mode. I'm just going to show you something you can do with it. But down the road, we may very well talk a little bit more about parametric mode. It's a way of defining the x-coordinate and the y-coordinate separately. Instead of y equals, you get to say x equals and y equals. And then go down 2 more, and instead of sequential, go to simul, which stands for simultaneously. So when your calculator graphs, instead of graphing y1 and then y2, simultaneous has it graph all the graphs at the same time. You know how it does one first and then the next one? Simultaneous would have it graph both functions at the same time. It's going to make my story work better. My picture story. Okay? So now that we have all of our settings done in mode, we can now go to y equals, and something crazy is going to happen.
Wait, they're all T's.
Yes. Okay. Yes, we'll just call it Travis mode. When you go to y equals, you'll notice that this you get x1 and y1. You get an x and a y, and you get x2 and y2. So instead of defining a function just in terms of y, you get to define it both for x and y. So go ahead and put in for x1 cosine t, and go ahead for y1 sine t.
Like alpha t?
Nope. Actually, that's a great question. I didn't say it. If you hit the x button, x actually can stand for x, t, theta, or n, depending on which mode you're in. And I am going to, I'm going to clear and clear. And if you do, right now, if you just do a zoom decimal, which is 4, I think, who asked this on Friday? Travis, was it you? Can your calculator draw a circle?
Yeah.
The answer is, did yours do this? Did it go all the way around?
Yeah.
Oh, good. I had mine turn on to the bubble guy. The bubble guy is one of my favorite guys. So if you go into the margin and you scroll through, I think it's the third or fourth option is the bubble guy. So your calculator drew a circle. Not bad, huh? But that's not what he's going to do, right? Is that all he wanted to show us? No, it is not. I wanted to show you the story of amphibian. So, go down to x2, and we're going to type in t. Jennifer, the nice thing is it's screencast, so it's all there. But why didn't you bring your calculator? Oh, my goodness. So, x2 we're going to let to be t, and y2 we're going to be sine of t. So, do you remember from Friday? Sine is that Ann's up and down or side to side, left to right?
Up and down.
Sine is up and down. Sine is a y coordinate. So we are going to graph Ann's up and down together with the circle. I'm going to go to window and I'm going to make a few more adjustments. That's fine, that's fine, that's fine. My x min, I'm going to make -1. And my x max, I'm going to make 2 pi. And pi is second exponent over here. I don't know what he said. I'm going to ignore it. My y min, I'm going to make -1. And my y max, I'm going to make +1. And I think before I do anything, because it might look a little weird, I'm going to go to zoom square, which is 5. And zoom square makes circles look like circles. And if you look at this story...
Whoa, it's awesome.
Alright, so I'm going to hit enter, which stops it. So look, here's Anne, and this is her height. Okay, so I'm going to hit enter, and it's going to unpause it. And here's Anne, and this is her height. Right? So as Anne goes around, this is a graph of her height. And if we hit enter again, we can let it go. And, oh, what happened right now to Anne? She went underwater, right? So here's Anne, and here's her height. She's under the water. And here she comes. She's still under the water, but she's on her way up. And finally, she's back to the riverbank. And certainly, she could do this over and over again. And if she did it over and over again... Say again?
Is this fun for her, or is this like animal?
No, it's fun. She likes it. This is what she does. And there's more to the story. She gets pies every once in a while. You'll see. But could be. Go ahead.
Normality on the circle there.
Oh, on this one? No.
It kind of jets out there as negative.
I don't know. Sorry, it's like it's
to a rock or something.
Yes, it's the folks at here. Sorry, wait, why is that there? I don't know. It's the folks at TI. Like they try their best, right? But this is as good as they get.
Whole circle's perfect except like 0.1 of it.
So if you got
Termination from
if we had like that TI Inspire, it would look even better. And I could probably get this to work on Sketchpad. You actually, to be honest, my guess is the first month you'd be confused, and then like you'd be better than whoever was teaching you with it. That's my guess. All right. I still have problems making calls on cell phones. I've never figured out which button to press. All right. So that was a nice story, right? You could also, if you wanted to, instead of graphing Anne's back and forth, you could graph her distance away from the y-axis. So if I were to graph it, how far away from the y-axis does she start off at?
Like whatever the diameter of the wheel is.
Yeah, and this diameter happens to be 1. She starts off 1 away. Okay? Is she getting closer to the y-axis?
No.
Say yes.
Yeah,
Yeah.
Oh,
Yeah, she is. So that means her distance is getting closer and closer to 0. Where is she about to go now? Nope. Nope.
all around the circle.
Nope.
Into the next quadrant.
Into quadrant 2, which is...
Very
You said all around the circle.
Yeah, the circle's in that color.
Okay, fine. But would it have been right for any answer? So she's now in negative And negative means to the left of the y-axis. Look! That's what the graph's doing. The graph is going underneath the x-axis saying, hey, she's to the left. And here she goes. She's about to go to the right of the y-axis, and that means her distance is going to be positive. So, look, here's another type of function that instead of describing how high above or below the water it is, it describes how far to the left or right she is. Okay? So, I think that's a nice visual tie-in to how the circle, how cosine and sine, and how that graph all sort of tie together. All right? I think I want to do like questions from the homework and do some classwork, but what do you was this better than Anne and the bicycle wheel, or just as good, or just another way of doing the same thing?
Could we tape the frog onto the bicycle?
All right, that would be key. I got to get the frog, not like a paper frog. You don't mean a real frog. No. Evan.
Now, like, switch the things there.
All right, so if you want to do stuff on your calculator later in the day, or maybe even tonight, you're definitely going to want to do things like go back to degrees, at least for now, go back to function, and then it doesn't really matter if you do sequential or simultaneous. You're used to seeing your calculator do sequential. So for those of you who are creatures of habit, probably go back to sequential. And you know what? I think I'm going to go back to everything just in case we have homework problems that we need to talk about. So,
Like, would this affect, like, normal problems?
the only part that's going to, well, there are two things that would affect normal problems. First of all, function and parametric, if the problems involve graphing, it would definitely affect it. And if your problems involve degrees or radians, measures of angles, then radian and degrees is going to affect it. So your big thing right now is not, we're going to go back to function and we're going to stay there, okay? But your big thing, starting tomorrow and the next day, is going to be figuring out if you want to be in degree or radian mode. So the mode button is going to be an important button for you for the next couple months. Okay? Tom?
I was going to ask later, like, I just don't get what, so the radians and degrees is affecting actual graph, because it's like, it's not like I put 2 times 2 and change the answer. Right?
No, it won't. But if you do the sine, how high up is Anne of 45 degrees? You get 0.707, so she's 0.7 up. If you're in radian mode, the sine of 45 will be a totally different answer. So degree and radian matters when you're doing trigonometric functions, when you're doing sine, cosine, tangent. It won't affect 2 plus 2. You're absolutely right. All right, Evan, and then let's do some problems.
Can I give a quick, extremely not related story?
Do I have a choice?
So, like, I was taking, this is when I first figured out that this class was actually useful. So when I was taking my SAT,
I hope you mean the first day of class.
yeah. So I was taking my SAT. There was a problem where we had like a graph, and then it was really confusing. But like, they gave you like half of a point, and they gave you none of a point on the other side. And you had to figure out like the y coordinate of it. So long story short, I was able to do like calc. It was calc 0, and then once I got that, then I did like calc trace. Then I just did trace on the other side, and I got the answer.
I'm happy to hear that. Thanks, Evan. Thank you for sharing. All right. So SATs are like 80%. That could be true, but 80% is arithmetic, like 6th and 7th grade math, algebra, and geometry. They just started putting more about functions on the SATs, and we do a little bit of functions in algebra too, but I agree, most of what we do with functions is pre-calc. And so, in some respects, pre-calc is a very nice course to have, either as you take the SATs or right before you take the SATs. And certainly, any of you thinking about taking the math subject area test, after you take pre-calc is a great time to take the math subject area tests. Okay, and you would take level 2 after you take pre-calc, you take level 2. Okay. All right. Elizabeth, Rafi, some others. What made you cry? What are we going to talk about? All right. Sam and then Corinne. 32.
Like, I drew graphs and tried to figure it out.
All right, so I think my hint to you was you needed to read about the London Ferris wheel. Is that true?
Yeah.
All right, so you have to tell me a little bit about the London Ferris wheel, and then we can look at the 17 minutes, 30 seconds. So what do we know about the London Ferris wheel? Diameter of 450, you said? All right, what else do we know?
It takes 30 minutes to do one rotation.
All right, so the period is 30 minutes. All right, so we can tell the amplitude from the diameter. Now, wait, are they assuming that the London Ferris wheel you get on at ground level?
Yes.
Okay, so that's a pretty big assumption. My guess is you probably get on a little bit above ground level, but they're maybe choosing to ignore that. Okay? So 30 minutes to go all the way around, and are we getting on at the bottom?
Yes.
All right, so we are getting on at the bottom, and we need to find out how high we're going to be. All right, so let's see. Do you agree? How long have we been on when we get to exactly the halfway or the midline? Set what? I think 15 is going to take us all the way to the top, right? So 7.5 minutes, right? I'm ready for your answer now, Elizabeth. 15 minutes. Okay, listen to what Corinne just said. Okay, so Corinne said, if we're going to go another 2.5 minutes, 2.5 minutes represents what? A third of that angle. So it looks to me like we went 90 degrees, 90 degrees, and then Corinne says 30 degrees. Does anyone have a question about how Corinne got this 1/3?
Yeah.
Okay, Corinne, talk to us a little bit. I see how you got it.
Well, it was like 7.5 minutes from 15 to 22.5 minutes. So then I divided by 2.5.
So if you had to divide up your 7.5 into thirds, wouldn't you get 2.5, 2.5, 2.5?
Yeah.
Is that okay now? You probably could have set up a ratio to figure that out. Like 90 degrees is to 7.5 minutes as 30 degrees is to what? Yeah, yes. All right. So we want to find out how high she is. And it seems to me that the important piece here is going to be this triangle, I think. I think that this triangle shows me how far over and how high up. But what's the problem?
Need the 60 degree.
30 degrees is not what I need. I need 60 degrees. And so now what I need is I need something that uses 60 degrees and will tell me her height. I guess this is an and, this is you. So Sam, you asked the question. His height. How can I use 60 degrees in this triangle to figure out what in the world his height is? Mo, thought or idea?
Like, so height, y equals radius
Sine or cosine? What's the y? The y is always going to be a sine or a cosine. Which one? Sine. Yeah, I love it. Mo goes back to the relationship y, whatever the y value is, always equal to r times the sine of the angle. Now the important thing is that angle has to be measured from the x-axis. If you did sine of 30 degrees, you'd get the wrong answer. So that was a little tricky. And we know, you already told me the radius is 225, then times the sine of 60 degrees. The sine of 60 degrees is like... Good. All right. Now, is that how high up she is?
That's the point where she that's the Y. So, yeah. Well, you're in it. Yes.
Sam says yes. Keith, is that how high she is? Yeah. Try again. No's the right answer. Miles, do you have a thought or idea why 194 is actually wrong?
Because that's only that's less than the radius, so it's we have to add 225.
Yep. Awesome. You hear what Clever Miles tells us?
Miles.
Clever Miles says that you have to remember that not only she's 194 up from the midline. Sam is 194 up from the midline. You have to add 225 to it. And if you take your 194 plus 225, you get something. 419. And that's how high up Sam is on this Ferris wheel. That was a very hard problem, don't you think? Let's can we summarize why it was hard? Okay, so first you have to come up with Corinne's clever way of dividing up the 7.5 minutes, which when we get down to it, just ratios. But still, she did it, and some of us didn't. So that was a clever start. Then we have to use Mo's clever y equals r sine of 60 if we're trying to find the height of that y value. And then we have to use Miles' clever, but that's just above the midline, so we still have to add on the radius of the wheel. So that was a lot of clever that went into this problem. So way to go, clever Corinne, clever Mo, and clever Miles. All right, so here's the thing. Here's the thing. A lot of what being clever is, now I'm not going to say that Corinne, Mo, or Miles had this advantage because they did this, but part of being clever sometimes is seeing someone else be clever so you can do the same sort of trick, right? So we've now seen a good approach to a problem like this, so you should be like, okay, I know how to be clever now and do a problem like that. All right. Corinne and then Sam.
Could you do that part? Could you flip the triangle so it's a 30-degree angle instead of a 60-degree angle?
So you want to do like this?
Yeah.
And then you want to do the cosine to find this value? So if you flip the triangle and use 30 degrees, then you have to do you have to abandon sort of Mo's relationship from the section before. You have to say, okay, this value is, whatever this is going to be 225 times the cosine of 30 degrees. And then you'll get the same answer. Okay? So yes, you can. But you have to keep in mind that sine and cosine don't always... Sine and cosine only tell us how high and how far if you measure the angle from the x-axis. If you start measuring the angle from the y-axis, sine and cosine tell us different things. Back to Sam.
So is this why you didn't want to put Anne's wheel partly in the water? Because you'd have to find the distance.
No, I think this is why I actually ended up doing the Ferris wheel and putting Anne's wheel in the water. Anne's wheel in the water is nice because when we graph it on our calculator, we can see that we go below the water. For the Ferris wheel, this means this is the midline. And
we tried to get you to put her wheel not in the middle.
Oh, you wanted me to put the wheel so it just touched the water. Yes, that's exactly why I didn't do it, because we already did it with the Ferris wheel, and I wanted to show you something different where the midline was actually the x-axis. Evan, and then another... You sure? All right, Corinne, you had a question way back when, or was that it? 27. 27, all right. That's interesting. So... it wants us to find an angle that has the same cosine as 53 degrees. Well, let's see. I'm going to draw a circle. So here's Anne at 53 degrees. Cosine is talking about what? Up and down or left and right? Left and right. So would you agree that let's see, sorry. We're talking about the x value. So we want to know what angle would Anne have the same x value. There's another angle where she's exactly the same distance from the y-axis. Actually, to be honest, you want to know? There are three other places where Anne is the same distance from the x-axis. 2 of them are negative, 1 of them is positive. So can you see that Anne's actually going to end up in this relatively the same spot, just left or right? I'd actually say this. Let's think about Anne going around the circle. Okay, so here she is here. I would say that right around here, she's the same distance from the y-axis. And I would say somewhere around here and somewhere around here. In all 4 of those spots, she's the same distance from the y-axis. Okay. In 2 of those spots, negative, and 1 of those positive, can we tell which quadrant is the cosine or the distance from the y-axis positive? We have, just to remind you, not that you forgot, I know you wouldn't. We have quadrants 1, 2, 3, and 4. Which 2 quadrants have the same cosine? 1 and 4. Cosine is positive in the first quadrant and in the fourth quadrant. It's negative in the second and third. Does that make sense with left being negative and right being positive? Is that okay? Okay, so the question is, now, actually, do you see this question isn't about the answer, it's about what the question means, right? Right, once we understand what the question means, I think we're all right. We have to go around. Can we take advantage of symmetry, do some reasoning, figure some things out? Tom, thought or idea?
Do cosine 53 equals feedback or adjacent or
Well, so I definitely can find out whatever this hypotenuse is, that the cosine of 53 degrees is going to be whatever x, the adjacent over the hypotenuse is. But there's going to be another place where it's going to be the same exact ratio. Michelle, thought or idea?
Well, I just did 360 minus 53 and got 307.
So if this angle's 53 degrees, you're telling me this whole thing had to be 307 degrees? Max? Okay. Let's actually go to our calculator for a second. Make sure you're in degree mode. Get back out of radian. If you type in cosine 53, it tells you Anne is 0.601 or 0.602 to the right of the y-axis. If we type in cosine of 307, it tells us that Anne is 0.602 to the right of the y-axis. So those cosines have the same value. Going back to my picture, does it make sense why those cosines would have the same value? So Michelle, go through what you were thinking again.
I did 360
Go all the way around, which is 360, and then
minus 53.
back 53 degrees. Gives you 307. I don't think so. As a matter of fact, could someone tell me when cosine is going to be negative 0.602? When am I going to get it in the... It's not going to be negative when it's...
27 degrees.
How'd you get 127?
90 minus 53 plus 37.
I think they're right, Sam. I'm not saying you didn't get it. I'm just saying it's a little simpler to think. Go 180 degrees and then go back 53 degrees. So if we go cosine of, what'd you say, 127? That's the negative. And there's one more spot where it's going to be negative. It's going to be 180 degrees plus 53. I totally agree, Elizabeth. So the cosine of 180 to 33? Great. And this is exactly why it's a periodic function, because it ends up, if we keep going, it'll repeat itself, all these y values, over and over and over again. All right, Sam?
So I thought they were asking what had like the same point. So I added 53 to 360 and got 413 degrees. Is that like...
All right, that would be okay, except, I mean, it's absolutely right. Sam's saying if you go 360 and then another 53, except the very first thing says find an angle such that the angle is between 0 and 360 degrees. You found an angle that was more than 360. As a matter of fact, if they don't put this restriction on it, there are an infinite number of angles you could find. Right? Just keep adding 360. All right. Nice question, Corinne. Rafaela. 17. All right, so find the coordinates of the point with a radius of 3.8, centered on the origin, and we need to do 1,426 degrees. Holy cow. Gesundheit. All right, so 1 time around is how many degrees? 2 times around is... 3 times around is... 3 times is what? 1080? 4 times around is... What is it? 1,440. Raphael, you say that's too much. It's too much by how many degrees? 24 degrees, we went over. So what we need to do... Wait, what is it?
14.
So we need to go 4 times around and then back 14 degrees.
3.8 sine, 14.6, 3.8
All right, wait, hold on, I'm not there yet. You guys are doing... So is that okay? So we went around 4 whole times and then back 14 degrees, and now I need to find the coordinates, and I think Mo will tell you that the x-coordinate is... No, not exactly what it is. In general. Radius times cosine of the angle, and remember the angle has to be measured, Keith, from the x-axis. And 14 degrees is measured from the x-axis. Right? Actually... You know what? It doesn't matter, but you're not going to like this. Well, hold on. And y is going to be r sine of 14 degrees, sine of theta. You have 2 options here. You can either do x is equal to 3.8 times the cosine of negative 14 degrees, because negative 14 degrees means we went backward 14 degrees, or 3.8 times the cosine of 346 degrees. Can you see how 346 degrees forward or going counterclockwise is the same as 14 degrees backward or clockwise? And this is actually a really good time to point out and make sure we understand. Whenever we're measuring angles on the unit circle, we're always measuring starting from the positive x-axis. And by default, a positive angle means that we are going counterclockwise from the positive x-axis. That's why I very specifically started and at this point, right? To start that model in your head, we start here and measure this way. If we say a negative angle, we measure clockwise from the positive x-axis. Is that okay? This is a lot. I know it's a lot. There's a lot of stuff. You have to read the book. It's tough. It's not easy. Evan, I think there's like 15 seconds. What do you got?
Oh no, I was just wondering. Is there like multiple ways to do these problems, or is there just one way?
So you need to know that 1,440 degrees. Oh, you know what? Okay, fine. That's enough out of you. Hold on. Keith says you could actually do 3.8 times the cosine of 1,446 degrees. Fine. That's okay.
You gave us an equation like the first day.
I can live with that.